today I'm going to be presenting another local catchment case study that you can know, which is the River Mersey in AQA level geography. A level, it sounded very weird when I said that, in water and carbon. So, the location. River Mersey and its tributaries drain, you can round that number to 5,000 kilometers squared. 113 kilometers long and flows through urban areas of Greater Manchester and Merseyside. Over 5 million people live and work in this catchment area. River Mersey is located in northwest England. It has two main tributaries, which is the River Tame and River Goyt, and have their sources in the surrounding upland area. The River Tame flows through an urbanized landscape. In the 19th century, it was an industrial area which resulted in the river becoming polluted with dyes and bleaches, but nowadays it's much cleaner due to anti-pollution measures. The River Goyt has its source in the Peak District. It flows through two major reservoirs which are constructed to provide the urban population of Stockport with a water supply. So the Lower Mersey catchment has increased urbanisation by 25%, and it's estimated that by 2100, 25,000 properties will be at risk from flooding, which is a 30% increase compared to the current number at risk. The depth of flooding is expected to increase, for many more properties experience flooding depths greater than 0.5 meters. Some flood risk is that the Upper Mersey has historically been subject to sudden periods of flooding. A number of notable flood events have occurred in the catchment between 1965 and 2002. An example is when in October 1998, 130 properties were affected by flooding. So 2,600 residential and commercial properties in the catchment have a 1% chance of flooding in any 1 year, which again is that flood recurrence interval, where the likelihood of a flood happening within a 1 year period is 1%, basically. The Lower Mersey, which has approximately 40% of the area heavily urbanized. The catchment is generally low-lying, and over 19,000 properties are at risk, 1% risk of fluvial flooding. Peat moorland help absorb some of the rainfall. However, in recent years, atmospheric pollution, peat extraction, and burning caused damage to these landscapes, resulting in more water reaching the streams and therefore decreasing the lag time on the flood hydrograph. In terms of the flood event that you can use as an example, is in the 20th of January 2021, Storm Christoph hit the UK, issuing over 200 flood warnings as 1 month of rain fell in a 2-day period. River Mersey came within centimetres of overtopping near Didsbury, leading to 2,000 residents' evacuations. Sluice, I don't know. Gates were basically floodgates were opened to allow water to flood Withingston Golf Club, which prevents the properties and businesses from being flooded because, as you've probably seen before, golf clubs have just massive expanse of just grassland, say. Boris Johnson said that we've put £60 million into Greater Manchester area flood defences, and there's another 20 million on the way, but I'd have to check if that 20 million was actually delivered. In terms of flood defences, the DEFRA updated their policies and set out that to protect further 300,000 properties and reduce the national flood risk by 11% in 2027. They set out that they will ensure that existing flood defences, such as a 5 kilometre flood wall and 2.2 kilometres of embankment, are well maintained, so they continue to be effective in changing climate with more extreme weather, introducing a more holistic approach to flood and drought risk to protect communities. A key strategy on floodplains is the sustainable management of space for water in areas which aren't settled, like, for example, that golf club. Hard engineering schemes have been put in place in the last 30 years, such as flood alleviation, 67 kilometres of raised flood defences, 3 flood storage areas at Sale. The result of this is a reduction in peak flow of 35% during the 1% annual event. In terms of the future, wetter winters and more intense rainfall may increase river flooding in both rural and urban areas or catchments. More intense rainfall can cause a greater surface runoff, which increases localized flooding and erosion. This may increase pressure on drains, sewers, and water quality. Future scenarios in Upper Mersey suggest a 20% increase in peak flow in all watercourses. Increased urbanization, 5 to 12%, and changes in rural land use will increase surface runoff and reduce lag time. It's estimated that in 2100, the number of fluvial flooding in the Upper Mersey catchment area will increase by around 11%, where nearly 300 properties are affected. Greater impacts is predicted in the main urban areas. Onset of flooding will happen earlier, possibly impacting on the ability to provide adequate flood warning. Here I've got some questions. Some of these, like I think the first one I've repeated from the River X case study, because you can try out with this one. I think this is a pretty good case study. And I also got a 6 marker. I don't know the 20 marker as well. Though that 20 marker is exactly related, but I think you could definitely relate to this case study to it. Here is the very long figure 2. Thank you.